I am going to talk about communication dilemma, and I am also going to be very topical. So I am going to talk about I resign. What does that mean? All of us are in the business of communication, so we should be interested in information transfer. How information gets transferred from one person to another person, or from communication media to a person. But for that we must have an idea of what is information. So let us try and define what is information. Can I have some opinions on what is information? Material that you have collected, okay. Awareness, okay. Knowledge, okay. Collection of data. We are dealing with information all the time, right? And why is it so difficult to define? Okay, the person who created information theory had 2 Nobel Prizes, okay, and it was his master's level thesis at MIT which started information theory and created an absolute revolution in communication. Okay. Very little of it is known purely because it was a very complex mathematical theory. Subsequently it influenced the whole issue of psychology, and I am going to talk about that aspect of it and not the mathematical part of it. So what is information? Let us try and experience what is information. Is there more information in the test match and between test match and the T2020? Which one has more information? Equal information. Test match. Okay. How many people for test match? How many people for T20? No, only 1. All right. 2. Okay. Does a railway timetable of a through train carry more information than say Jet Airways or some airways timetable? Which one? Huh? Railways. How many people for railways? Okay. I am getting you into a trap. Huh? Suppose you are driving and you see a pedestrian walking, does that carry more information than the street signage? Pedestrian. How many people pedestrians? Only 4 or 5. The rest thing believe that street signage, they are all designers. Slight twist in that, if a pedestrian is a child, this is exactly what happened with information theory. It turned our common sense understanding of information exactly topsy-turvy. Okay. What we consider as information in our common day-to-day communication was exactly turned around. Okay. Let us see what happens. Okay, just imagine that there is a message which is being sent and some of the letters get garbled. Okay. So the first one, that middle letter, second one middle letter, and then there are those underscore would mean that that letter is not printed, somehow it gets lost. Now which of these spaces, there are 5 empty spaces there, right, in 5 words. Which of the spaces carries more information? So last one carries more information.
Probabilities for the first, because it could be any number of vowels.
So which one would carry the most?
The first one.
First one carry the most information. Okay. Can you rate them in terms of order of least information to the maximum information? 1, 3, 2, 4, 5. Let us look at what are the alternatives possible in English. First one has 4 alternatives, second one has 5 alternatives, third one has got 2, fourth one has got 2, but if you look past tenses then the third one, and the last one has no alternative. So the last one according to him carries 0 information, and the second one carries maximum information. So he just simply defined information as number of probable answers which are possible. Now this is exactly the other way of looking at it. Okay? Saying information comes from uncertainty and not from certainty. While we are looking at data, while we are looking at usefulness of information, we are all talking about information that way. He exactly turned it around, saying information is uncertainty. Look at his definition. Information is inversely related to the potential of reconstruction of message with accuracy. If you can reconstruct that message with accuracy, then anything that's missing does not carry any information. So PT doesn't carry any information because there's no other word possible at all. While the second word carries maximum information because there are 5 alternatives and you got to worry about which is the correct one, correct? So when there are 2 equally probable answers, outcomes, that means 50% of chance of first being right and another 50% of the second being right, then it carries 1 bit of information. Now you would have heard about these bits, right? It's used in electrical engineering, you also talk about in computers, so many bits of, so his definition is if there are 2 equally probable answers, then it has 1 bit of information and it's a logarithmic scale. So if there are 2 alternatives 1 bit, 3 alternatives 1.58, 4 alternatives 2 bits, 8 alternatives 3 bits, etc. It just goes on and on and on. Okay. We are not interested in the mathematics of that. What we are interested in is how do we use this as a part of communication. So according to him, outcome that can be predicted accurately and thus PT does not carry information. So remember the test match. Now let's look at test match against T20. By second day, more or less, we knew who is going to win the last test. So was there a match left? There was no match, right? It was only a technical kind of thing, who scored how much, whether Tendulkar completed his 100 tons or something like that. Besides that, there was nothing left in that match, right? Because there is no uncertainty, it had very little information, and very little information is very little interest. So as a communicator, you should be interested in interest, right? How do I catch people? And that's exactly why T20 and ODIs are that popular, because they maintain the uncertainty till not only the last over, sometimes to the last ball. You don't know who's going to win. So the format that is created completely satisfies these conditions of maintaining uncertainty all throughout. Now if you look at railway timetable and jet airways timetable, who is on time more often? That carries little information. Yeah, Indian railways are known to have delays. Of course, they have their own problems. I am not blaming them. So that carries more information than jet airways. Not because it's big, but because it's more uncertain. Right? Newspapers are famous for giving ambiguous titles. Yeah, let's do a little bit of a game. I'm just going to talk about papers in the last 10 days. I'll give you some titles. Please write down what what it refers to, what stories it refers to. Done? Next. Okay, next. Next. Last. Okay. Let's guess what is the first one on? What is the second one on? All right. What's the third one on? Big titles, not just titles. They come bold. Losing grip. Putting Mumbai to test. Not a bad story. It was politically motivated move. Painting a painful picture. It's about pain in the cricket team. Losing grips about Nadal and Federer losing the latest Cincinnati. We all know that uncertainty works, except that information theory tried to put it down, and that's the reason why information theory influenced advertising a lot. And that's how advertising, it happens more often. It's deliberate. I'll show you some examples of advertising also. So information is equal to ambiguity. You can create, there are different strategies by which you can create ambiguity. So that is how I started with iDesign, today's newspaper. I brought it and see how the focus is created on iDesign by changing the color, etc. Of course, then it explains about iCloud, iPhone and all that kind of thing. So point that I am making is uncertainty is used extensively to create interest and get attention, and I will show you that through whatever happens now. When the information is not direct, it makes it interesting, and that is exactly what advertising does. Chipping in is actually about electronic chips which go into this notebook. Not a nice suit refers to even Microsoft uses that, no? Office suit and things like that. So information is being indirect and also being interesting, and this is where the dilemma starts. If you create so much of things for interest, how do you transfer information? Okay, so let us look at problems that uncertainties create. Okay. First is, it is very clearly known that learning difficulty is directly related to the amount of information or complexity of the pattern. That means if the pattern is more informative, the more difficult it is to learn. Okay, and I will show you some examples of that. Visual information, these were the experiments which are done post Shannon's idea about information. So let us look at how the information was measured as far as psychology is concerned. Suppose you have each cell which can either be a blank or can have a dot. That means each cell has one bit of information. Yeah. So this 4 cell matrix, the 2 by 2 matrix has 4 bits of information, 9 bits of information and 16 bits of information. That is the way information is measured, and the way cell is blank or the way it has a dot is completely randomly decided. So there is no way of knowing, but 50% time it will be white, 50% time it will be blank. It will be white and 50% time there will be a dot there. Now you can always create patterns. Oh, that is another thing, information is an additive property. So what they did is they created a cell of 12 by 12 which was randomly filled. Now you can see on the left side 12R, randomly filled cells which created some pattern, right. Now they created 2 alternative patterns out of it which had 20 cells. So on the middle row you can see random pattern which is continuing, so it becomes 20 bits of information. On top also there is a 20 bit of information, except that there is a symmetry, it is reflective. Now they did it further by reflecting it this way, and now you have 2 things, one is 35 random patterns and other one is 35 cells with symmetric patterns. It has a 2-axis symmetry. Several such alternatives were done and people were given to they were shown this and then they were asked whether you have seen this before after some time. This is a proper test in which say you have about 20 of them shown, after that there is some time and after that you show some of the new ones you add with that and say whether you have seen it before or not and whether you recognize that pattern. Look at the results. On the vertical scale is the errors, okay, and the horizontal scale is the number of cells, that means amount of information. Whenever there was a symmetry used, there is an increase in the information, but if you compare vertically 20 which are done, 20 cell patterns which are completely random and 20 cell patterns which are symmetrical, there are more errors in random pattern. Same thing happens if you compare 35 which are completely random and 35 which are symmetrical, which also means that a 35 cell symmetric pattern has far fewer errors than 20 cell random pattern. So you could see how you can control information the way you want. They did this kind of work with even mentally challenged children, and they found that they are able to recognize simple patterns like symmetry. For instance, symmetrical patterns they were able to recognize and they were able to reproduce it, but whenever it came to finer things like these line formations or these kind of symmetries or repetitions, they were not able to do it. There are a lot of such things that happened during that time to prove that more the information, more difficult it is to learn, and yet we are interested in learning. So how do you tackle that issue?